Hello everyone, today we are going to discuss wave function. Wave function. So the wave itself, wave function means that the wave, displacement of wave basically is a function of, position and time. Okay, here x represents position and t represents time. Means that when a particle is moving in a wave, this particle position and time will specify the wave motion. Okay, so this is basic function for wave. So wave depends on two factors, that is position and time. Okay, so we know that wave is a collection of objects having simple harmonic motion, and we have also studied that the simple harmonic displacement for simple harmonic motion is equal to x amplitude sine omega t. Okay, so this where a is amplitude and this is the phase angle. So suppose this is an object. Related to this object, when we displace the position of this object, it will produce its kinetic energy, and because of this kinetic energy, this motion will be transferred to another particle nearby, and so on. So this second particle will transfer its kinetic energy to the third particle, and the third will transfer its kinetic energy to the fourth, and so after some time, the motion will be transferred to this particle at its specific position. Okay, keep in mind that during wave motion, the particle does not travels. The particle oscillate at their own specific position. Because of this oscillation, the kinetic energy which is produced, this kinetic energy will be transferred from particle to particle. So this at this position, and after this specific time, here the time was 0, and the displacement of the particle was also 0, and after x, okay, after some time the displacement of this particle would be different. So wave motion, this y represent displacement is equal to alpha sine omega t. Okay, now we know that in wave motion all the particles, they are having wave motion, so we will start from the simple harmonic motion equation. Now omega t, after some time this wave motion will T1. So this is the final time or TF, and this is the initial time. After completing one phase, the particle, the different particle would have different oscillation from the first. So that's why after some time, it means that with change in time will specify the wave motion. So we know that Tm, that speed of this oscillation will also bring change in the speed of the wave motion. So the speed of the oscillation is equal to, we know the speed formula is equal to distance over time. Here this distance is the displacement of this particle, so v is equal to x over t. Okay, so after some time, this will have its own displacement, oscillatory motion. So v is equal to x over tm. Final time would be equal to x over v. Okay, so we will put, instead of tm, we will write this form. Okay, and omega, we know that in simple harmonic motion that we studied, that angular velocity is equal to 2 pi over t. So we will put omega value in this equation. So the equation will become y is equal to alpha sine 2 pi over t x over v minus t1. Okay, now we will multiply this term with this expression. So it will be alpha sine 2 pi x over time period and velocity minus t minus 2 pi t over t. So we know that 2 pi over t, this tv, we know that speed of wave is equal to frequency multiplied by time wavelength, and we know the frequency is equal to 1 over t. So v is equal to 1 over t multiplied by wavelength. So wavelength will come out to be velocity multiplied by time period. Okay, so alpha sine okay, so instead of 2 pi x over lambda minus, now 2 pi over this term 2 pi over t, this 2 pi over t is equal to angular velocity, so minus omega t y. Now keep in mind this 2 pi over lambda, this is equal to 2 pi over lambda, this is equal to k. What is k? K is the wave number of waves. Okay, how many waves are passing per unit time, this is k. Okay, so y is equal to alpha sine kx minus omega t. So this is basic wave function. Now if for example this is a wave, okay, and it is moving. Now we want to find the wave function at this point after some phase. So keep in mind that this equation is for the wave where we have phase angle 0. Okay, means that at this point this wave function is applicable. Now if you want to find the wave function at this point, we need to bring some change. What sort of change? That is equal to y alpha sine kx minus omega t plus phi. This 5 may be pi over 2, maybe 2 pi, maybe 5 pi over 3, any value, any phase change. So that phase angle is over this equation at the origin, from origin point we are going to use this equation. Okay, but after other than origin, like this point or any point on the wave function, we are going to use this wave relation. Okay, now keep in mind that this part, which is the phase of, which shows the phase of the wave, this is actually the phase of the wave. Okay, this is amplitude and k is wave number. This is basically shows the property of the wave. Okay, let's analyze this portion of the wave, that y is equal to alpha sine kx minus omega t plus phi phase. This is basically phase of the wave. Okay, here k is wave number. Now by phase we mean that this is actually the constant, or we can say that it is actually the characteristic property of the wave. How? That let's assume this is constant. Okay, so let's assume that kx minus omega t is equal to 0. So definitely kx is equal to omega t. Okay, keep in mind that if there are if the sign between these two terms, are different sign, so the wave direction would be along positive x-axis. Why? Because you see here that these two terms are having different signs. Now after analyzing both the wave, both this term, they are having plus sign, so it means that the direction of the wave is along positive x-axis. So if I want to find the value of k, that would be equal to k is equal to omega t over x. So t over x is the ratio of displacement and time, so definitely this k is equal to omega over v. So this is omega over v, and we know that 2 pi omega is equal to 2 pi over t, so we'll put the value of k is equal to 2 pi t v. Okay, so this is tv. We know that k is equal to 2 pi over lambda. So you can use this equation as well, this equation as well as this one as well in some questions. So k is equal to omega angular velocity over v, over velocity, and we can, from this equation we can also find that speed of wave is equal to omega over k. Omega over k. Okay, keep in mind that if these two terms are having different sign, thus the wave direction is having positive x-axis. But what happens if both the sign of these terms have same sign, like for example kx plus omega t, same sign? So definitely if you bring this term on that side of the equation, it will have minus omega t. So what will happen? The wave will travel along minus x direction, means the wave will travel along left side. Okay, so if there are kx plus positive, same sign is present between these two terms, so the wave will traveling on this side of the x-axis, on the negative side of this axis. And if inside the wave function both these terms are having same sign, different sign, the wave will travel on that side of the x-axis, means towards the positive x-axis. Okay, now from this relation we can also find the velocity, that kx minus omega t is equal to 0. We can also find the value of omega, kx is equal to omega t, x over t is equal to omega over k. So omega x over t is speed, omega over k. So this is also another formula for speed, and in this way you can find the relation from this equation.